as compared to the list is that numpys are implemented in such a way that they are stored at the continuous places in the memory, unlike in case of list. So the process can access and manipulate them very efficiently due to the concept of the locality of reference. Okay. So the numpy arrays are stored at the continuous locations. So therefore it is faster to access them. Right. So the IO operation reduces a lot of time and it is 50 times faster than the list. So it is better to go with numpys when you need array kind of structures. All right. So we can create one-dimensional array, zero-dimensional array, two-dimensional array, three-dimensional array, any dimensional array using the numpys. So to create a numpy array, we call numpy.array, right? We call numpy.array. I'll show you how to create zero-dimensional, one-dimensional, two-dimensional, and three-dimensional arrays. So to create an array, call np.array. np is the numpy library. And if you are creating a zero-dimensional array, then you just pass some scalar value to it. So some number you can pass, right? So this is a scalar value that you are passing. I mean, single value that you are passing. This creates a zero-dimensional array. You can see that to see how many dimensions are there in the array, you can just print a dot n dimensional. So I'm printing both a and the number of dimensions in a. So a dot n dimensional, number of dimensions, n dimensional means number of dimensions. So I'm just printing that. You see that this is 6, the value is 6 and the number of dimensions are 0, right? As it is a single value one, not the list of values, right? So similarly, I can create a one-dimensional array like the same process, np.array. Here this time, if you want to create a one-dimensional array, you pass this single list, right? 1, 2, 3, 4, 5, let's say. Okay. And similarly, you can repeat the process. You can just print B and also the number of dimensions in B. See that? So this is the array 1, 2, 3, 4, 5, and the number of dimensions in it is 1, right? So similarly, you can create a three-dimensional array also, four-dimensional array also, whatever that you would like. So here I'm just giving you a two-dimensional array. It means of list I'm passing as the input here. Okay, list I'm passing. This creates a two-dimensional array. Similarly, you can have three-dimensional. You see that it is a two-dimensional, right? It's like a matrix, right? So you can perform any matrix operations on the numpy arrays like multiplication, subtraction, addition, dot product, whatever that you would like to perform, inverse operations, eigenvalue computation, all that we can perform using the numpy arrays. That we will see as we proceed. So this time I'm taking the three-dimensional array. So 1, 2, let's say 3, 4. So let's say this is one two-dimensional array. Another two-dimensional array is this 4, 5, 6, 7. This is another two-dimensional array. Total it is three-dimensional array, right? So let us just name it as a D. You see that? This is the three-dimensional array in which we have two-dimensional arrays. So this is an array of size 2 by 2 by 2, right? 2 by 2 by 2. Right? 1, 2, 3, 4, 4, 5, 6, 7. Okay, three-dimensional array. So like this, we can create any number of dimensions. Now, the next one is how to access the elements in the numpy array. It is much easier as compared to this list also. Okay, so we'll see how to access. Let me take B for the purpose initially. So I'm printing B for our reference. So how do we access a single element in the list? How do I access single element in the list? Suppose I want to access indexing, right? So B of 2 if I pass, what do I get? I get 3, the element that is located at that location, right? So if you want to access a slice of elements, then slice of elements 2, 3, 4 I want to access. What will you write? What will you write if you have to access 2, 3, 4?
1, 5.
1 is to, what is the ending index? Ending index is 3 plus 1, 4 you have to write here, right? So you're accessing 2, 3, 4. So suppose if I give 1 is to 4 is to 2, step size 2, what it will print? Starting from 1,
2, 4.
first index, and ending at the third index, 4 minus 1, third index, and with the step size of 2. So what it will print?
2 4s.
2, 4 it will print. Okay. So the accessing a single array is same as in case of list. Okay, single numpy array is same as in case of list. So see how to access the double dimensional array also. So here I'm taking C for the purpose. So which is the double dimensional array. Suppose I want to access 2, 3. I just want to access 2, right? How do I do that? I'm just accessing C. So the row number I'm mentioning, which is row number is 0. I mean row indexing is 0 and column indexing is 1. That's what the 2 is, right? So yeah, I got access to the 2. So row, you need to specify both row index and the column index in this square brackets separated by the comma. Suppose if I specify here 1 comma 1, then what it will print? It will print 5.
5, 5.
The slicing operation also can be done in case of this numpy arrays also. Like for example, I just want to print first element in all the one-dimensional arrays. It means all the inner arrays, right? It means all the rows. So I just want to print first element in all the rows, right? So I repeat it over all the rows. I'm just taking column here. It means it is repeating from the starting row to the ending row, right? So if you want to specify, you can specify some numbers also. If I want to go 0 to 2, like that you can mention. If you want to go over all the rows, you can just give column there. So here I'm just repeating starting from 0 row, ending at first row, and I just accessing the first element. It means the element that is present at the 0th index. So it will print 1 comma 4, right?
Yes.
So right, so if I give 1 here, then what it will print? Hello
2, 5.
everyone, 2 comma 5,
5.
right? So if I give 2 here, then
3, 6.
3, 6, yes, right? So similarly, this you can do for I'm just commenting this. So this you can do column wise also. Suppose I just want to print every element present in the first row. Okay, all the columns. Okay, first row, all the columns. Then, so here row is not changing. So 0 only, first row. You should repeat it over all the columns, right? Alright. Even if you give this also, it is the same. Okay, 1, 2, 3 it gives. Okay, even if you give 0 comma column also, it's the same. But this will be useful if you want to access a particular columns. Like for example, I just want to access 2 comma 3. 2 comma 3. 2 and 3. What should I write here? I'm starting at index 1 until the end I am proceeding. Right? So this will take 2 and 3. Okay. So can you tell me how to write, how to get 5 and 6? 5 and 6. What should I write? 5 and 6.
1 comma.
I should give 1 here, right?
Yes, yes.
Okay. So 1 is to 5 comma 6.
Yes.
Suppose I just want to access 2, 3, 5, 6. 2, 3, 5, 6. It means the last two elements in the first row and the last two elements in the second row also. 2, 3, 5, 6 I want to get. What should I write here? I should repeat it over both 0 and 1 columns, right? Or all the columns, let's say. I'm just giving column. See that? It's printing 2, 3, 5, 6. So have you got an idea about how indexing works in NumPy arrays? Is that clear? We'll see if it is not clear to you. Okay, so let us take another array. Let us take 3 by 3 arrays. This is not so. One, two, three, 4, 5, 6, 7, 8, 9. Let's take one more two-dimensional array. 10, 11, 12, 13, 14, 16, 17, 18. This done, this is done. All right. So this is the array. Okay, so tell me, how can I access the first two-dimensional array, like 1, 2, 3, 4, 5, 6, 7, 8, 9? How can I access that? Three-dimensional array, it looks something like this. Can you tell me what I get if I just print d of 0? D of 0. What will I get? The first two-dimensional array in the three-dimensional array. The first two-dimensional array, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is printing that. So if I give d of 1, then what it will print? It will print 10, 11, 12, 13, 14, 15, 16, 17, 18. Isn't it? 10, 11, 12, 13, 14, 15, 16, 17, 18. So now question to you. Suppose if I, instead of taking one dimension here, let's take, I've taken this d comma 1 comma 0 comma 0. What it will print? 0 comma 0. It will print this 1, 2, 3, isn't it? It means it is looking for the first two-dimensional array. In that, it is again looking for first one-dimensional array. So it will print 1, 2, 3. Right. So if I give 0 comma 1 here, then
4, 5, 6.
4, 5, 6 it will print, right? So if I give 1 comma 0, then 1 comma 0,
10, 11.
10, 11, 12. Thank you. Okay. So let me again print this D for reference. This is D. So now I'm taking the three dimensional values. So D of 0 comma 0 comma 0. Okay, what it will print? What do you think it will print? 0, 0. 0 it, this 0 specifies you're referring for the first two-dimensional array in the three-dimensional array. And this 0 refers that first, it will print 1, right?
Yes.
This will print 1. So now, suppose the slicing also can be done here. Like for example, I just want to print the first one-dimensional array in all the two-dimensional arrays. It means I just want to print 1, 2, 3, and 10, 11, 12. Then you can repeat it over all the things. Column you can give here. Then you see this. What it is printing? 1 and 10 it is printing 0, 0, right? So suppose if you want to print all the one dimensional arrays, you can give column here also. You see that 1, 4, 7, 10, 13, 16. So this means that you're repeating it over all the columns. So suppose here I gave 0 here, but here I gave column. Then you see now that it is taking 1, 2, 3, 10, 11, 12. Okay. So like this, you can go for this slicing on any dimension. So can you anyone tell me how can I access 2356? 2356. 2356. 2356 is in which two-dimensional array? 0, right?
Yes.
And it is repeating over how many one-dimensional arrays? 2 one-dimensional arrays, first and the second. So 0 is to 2. Okay. And what do you want actually? You want
2, 3, 4, 6.
starting from first index, rest of the things you want, right? Okay. 2, 3, 5, 6. 2, 3, 5, 6. Got it. So can now tell me how to access 4, 5, 7, 8. 4, 5, 7, 8 and also 10, 11, 4, 5, 7, 8 and 13, 14, 16, 17. 4, 5, 7, 8, 13, 14, 16, 17. Tell me. What should I write here? 0 or colon? Colon? Right. It means I'm repeating over all the two-dimensional arrays. And what I want 4, 5, 7, 8 means I should start from the index 1 and till the end I'm proceeding. And 4, 5, 7, 8 means you're starting from the beginning and 0 is to, if you don't specify anything also, by default it is 0 only. 0 is to 4, 5, 7, 8. No, it is 1. No, 0. Sorry, 0 is to, see that 4, 5, 7, 8, 13, 14, 16, 17. So like this, you can use the indexing. Very easily you can access the NumPy arrays. Okay, better than list. Is that clear? How to use the indexing? Or should we try more examples? You tell me now. We'll wind it up. What is this? How to access 5689? 5689. If you tell, then only I will write. 5689. Hello, anybody is there?
Yes, yes. Colon.
5689 only. I'm not asking for 5689, 14, 17, 18. 5689. It means only the first
0 from
two-dimensional array. 0. Yeah.
1 colon.
1 colon. Will this work? 5689. So what this 0 specifies? 0 specifying that I'm accessing the first element in the three-dimensional array. What is the first element in the three-dimensional array? Isn't it this two-dimensional array? Hello?
Yes, yes.
Yeah, you're going for that. Now this specifying that I'm starting from the index 1 in the two-dimensional array. In the two-dimensional array, if you start from index 1, what it will access? 4, 5, 6 and 7, 8, 9, isn't it? So in that 4, 5, 6 and 7, 8, 9, what you want to access? You just want to access 5, 6 and 8, 9. It means you're starting from where? Index 1, right? Starting from index 1 and till the end you're proceeding. Okay. So this is 5, 6, 8, 9. Got it? Is that okay? Shall we move on? Have you got it? How to access indexing? Is that clear? Everyone? Oh, not many responses.
Sir,
Following or not?
you can repeat one more time.
Repeat one more time. Okay. We'll take the two-dimensional for your convenience because you're confusing a little more. Here tell me. How do I access 1? If I just want to access 1. C of? What should I write? To access 1. Where 1 is lying?
0, 0, sir.
0, 0 location, right?
Yes.
Yeah. So if I have to access 2, then
0, 1.
0, 1. If I access 2, if I have to access 5,
1, 0. Sorry, 1, 1.
1, 1, right. Now, instead of this single element, suppose I want to access the multiple elements. Okay. I just want to access the multiple elements. Next, I just want to access 2, 3. 2 and 3. What do you write? 2 and 3 present in one row or multiple rows? Both of them are under the same row, right?
Yes.
Right. So what is the row number?
0.
Row index number?
0s.
0. 0, comma. Are they present in single column or multiple columns? 2 is at one column, 3 is at another column. What are the index numbers for them? What is the index number?
1, 2,
Column index number 1 and 2, right? So starting from 1 and ending at 3. 3 means 3 minus 1 you will get. So it means
Yes.
you will starting at 1 and ending at 2. Right?
Sir?
So this will fetch you 2 and 3.
Topic?
Now
Yes.
suppose if I want to access 5, 6, then
1 colon.
1, comma
1 colon 3.
1 column 3. Okay. Suppose if I want to access 2 and 5. 2 and 5. Are they in the same row?
No, sir.
No. It means you have to repeat it over multiple rows. What are the rows?
0, 1.
0 and 1.
Yes.
Right. It means 0 is to 2 you have to write, or even if you directly write the column also, because only 2 rows are there, it will repeat it over all the rows. Right.
Yes.
You can directly write column. And what are the column numbers? Column number is only one column, right? 1.
Yes.
Right. You just have to write 1 here. 2 and 5. Right. Suppose I want to access here 1436. 1436. Just tell me. 1436. Print C. 1436. Are they in the same row or multiple rows? Multiple rows. Are they covering all the rows? They're covering all the rows. So you can directly take column here.
Yes.
Okay. Now 1436.
Hmm.
So 1 and 4 are at 0th column,
Yes.
and 3 and 6 are at the last column. So you can repeat it over all the columns, or you can write the numbers also 0 is to 3. And what is the step size here? Step size is 2. Then you see that it is accessing 1436. 1436. Got it?
Yes.
Hello. Is that
Yes,
clear?
sir. Yes. Yes.
Yeah. Now let us go to the 3-dimensional. 3-dimensional, along with the rows and columns, you have also got the depth, isn't it? So if I give d of 0, what it will print? The first 2-dimensional array in the 3-dimensional array, isn't it? So what is the first 2-dimensional array in the 3-dimensional array? D.
1, 2,
Speak loudly, no? 1, 2, 3, 4, 5, 6,
7.
8. So this is what it will print. So in this, suppose if I want to access a particular row, a particular row, I just want to access 4, 5, 6. What should I write here? 0, comma 1, isn't it? Which is the first row. Index, I mean the row index is first, right? So it is printed 4, 5, 6. If I give 0, comma 1, comma 0, what it will print? Hello guys, you need to be thorough. Quickly tell me. 1, 0, 1, 0. 0. This 0 specifies the first 2-dimensional array. It means it is referring to this 2-dimensional array. And this one specifies that it is referring to the second 1-dimensional array in that 2-dimensional array. It means it is referring to that 4, 5, 6. Okay, this 4, 5, 6. And again in that, what you are referring? 0th element. What is the 0th element in that?
4.
4.
Okay.
Okay. Suppose if I specify 0 is 2 here, then what it will print? Both 4 and 5, isn't it?
Yes, sir.
Okay. Suppose if I give, instead of 1 here, I give 1 is to 3 here. It means what? You're repeating it over the two indices 1 and 2 in the one dimensional arrays. It means you're referring to 4, 5, 6 and 7, 8, 9. In that you're accessing both 0th element and the first element. So it will print 4, 5, 7, 8. Isn't it?
అదేలే సార్ నేను
4, 5,
చేస్తాను
7,
కాకపోతే
8.
నేను నెక్స్ట్ మంత్ లేకపోతే
Have you got the idea how it is working?
నేను చేస్తాలే సార్ అది వేరే వాళ్ళకి ఇప్పుడు
Hello.
నేను
Yes, you repeat last statements.
Last statement. Okay. So 0 means the first two dimensional array, right? Which means it is referring to this 1, 2, 3, 4, 5, 6, 7, 8, 9. Isn't it? So in that you are referring to 1 and 3 columns, 1 and 2 columns. Sorry, 1 and 2 rows. Right, sorry, 1 and 2 rows. It means you're referring to 4, 5, 6 and 7, 8.
రూల్ నెంబర్స్ ఉన్నాయి ఇన్స్ట్రుమెంటేషన్
In that you're referring to what elements? 0 and first element.
ఇప్పుడు ఎడ్యూ
So
ప్రైమ్
what is 0 and first element in this row? 4, 5. What is 0 and first element in this row? 7, 8. So it is referring to 7 and 8.
Yes.
అంటే విజయ్
Suppose
సార్
if I have to access 4,
విజయ్
6,
సార్
7, 9, what will you write? 4, 6, 7, 9.
అదే సార్ ఎందుకంటే ఆయన అటెండెన్స్ పోస్ట్ చేసినట్టున్నారు కదా
Will this
అది
change?
ఇస్తే కనుక నేను ఇక్కడ ఈ రెండు నేను తీసుకుంటాను ఎవరో
It will not change
అవి మూడు
because
కలిపి
you're still referring to the first two dimensional array only. Will this change? It will not also not change because the same numbers, same row numbers, right? Will this change? It should change, right?
నేను ఇప్పుడు FDP
0 is to 3 with the step size of,
FDP
then it will open 4, 6, 7, 9.
FDP
Got it?
Yes.
Got the indexing? Okay.
FDP సార్
How to copy this?
12 వరకు
How to copy this numpy arrays? So let us take
అదే
print
జస్ట్ మీరు
int b.
మెయిల్ పెట్టినా ఓకే
To copy this b, we use b dot copy. So b equivalent to b dot copy. Then you will have this. You can print both b and b copy also. They both of them are same. Okay. Both of them are same. And if you directly assign no, like b copy equal to b, it will copy by reference. It means whatever the changes that you are making to b will all b copy will also be reflected in b, or vice versa, right? So now you see that I'm making some changes to b copy of 1 equal to 0, and after that again I'm printing both b and b copy. Now you realize that whatever the changes that you are making to b or b plus b copy, it will not affect the other. So I'm making changes to b copy, and you see this, it's not affecting in b, it's not reflecting in b. So if you want to copy the values, you just have to copy by b dot copy, or you can copy it through indexing, right? B of column you give, it will copy the individual elements. There is another thing, that is b view also there, b dot view. It will just view it, it will not create a copy of it. It means if you call this b dot view, b view equivalent to b dot view. Okay, so in this case, whatever the changes that you are making in b view will also be reflected in b actual original value, right? So I'm just making changes to b view of 1 equal to 0. Now you see that here I'm printing both b and b view slash. You see that whatever the changes that you're making to b view are also reflected in b, right? So if you have to make a copy, you have to call b dot copy, all right? Otherwise it will make changes to the other value also, all right? Then I will show you two functions that we most widely used in NumPy, that is shape and reshape. Suppose I just want to get the shape of B, right, or shape of C. Let me print them first. So just tell me, what is the shape of B? What is the dimensions of B? Isn't it 1 by 5? Dimensions of B. Hello.
Yes, sir. It is
1 by 5.
yeah.
What is the she's set? If it is a matrix, what is the size of this matrix? Isn't it 2 by 3?
2 by 3.
Alright. So this is of shape 5 comma nothing, right? I mean, it's just a one dimensional. That's why it is 5 comma nothing. If you give C dot shape, then you got 2 by 3. Let us print D. This is D. Can you tell me by looking at this and tell me what is the shape of it? Shape of D. Just look at it and tell me. No, it's 3-dimensional. What is it? Is it 2 by 3 by 3, or is it 3 by 2 by 2, or is it 3 by 3 by 2? What is it? What is it? How many 2-dimensional arrays are there? How many 2-dimensional arrays are there? In D, how many 2-dimensional arrays are there? 2, right?
2, sir.
In each 1-dimensional array, how many 1-dimensional arrays are there?
3, sir.
In each 3. In each 1-dimensional array, how many elements are there?
3.
3 elements are. So this is of size 2 by 3 by
3 by 3.
Okay, so this is the shape. Suppose you want to reshape it. Okay, so you want to reshape it. Like for example, let me take this. This is B. I'm just reshaping it. Okay, so reshaping it to, let's say, this is 5 elements only, right? I just reshape it to 1 by 5. And then 1 is already 1 by 5, 5 by 1. Okay, you see that? It's reshaped, right? Here you see this. It's reshaped as 1 by 5, isn't it? Sorry, 5 by 1. Let me cut this. So this is the original B 10345, which contains 5 elements. Now you're reshaping it to 5 comma 1, right? 5 comma 1, 5 comma 1 means 5 by 1, right? It means 5 rows and 1 column, right? So it means it should be compatible. Whatever the reshape size that you are mentioning here, it should be compatible, right? Okay, let me take another one. So this is the original C, which is of size 2 by 3. What are the compatible sizes to reshape for 2 by 3? Compatible sizes?
3 by 2 and 1 by 6.
3 by 2, 1 by 6, 6 by 1. All these are the compatible sizes, right? So let us reshape it to 3 by 2. So it just returns the reshaped value. It will not make changes to the original value. So if you have to make changes to the original, you have to make assignment operation. C equal to C dot reshape. So reshape of what should I pass here? 3 comma 2, right? So see that it is converted to 3 by 2 array. Okay. So if I don't pass anything at this location, right? At this location, at the place of number of rows, right? By default, it will take, I mean, if I specify -1 here, by default it takes the size compatible with the other dimension. So what is the size compatible with the other dimension? How many total number of elements? 6 elements. If one of the dimension is 2, what should be the other dimension to make it compatible? It should be 3, right?
Yes,
It
sir.
automatically take that. Similarly, even if I don't specify the exact number, but I just gave -1 here, then it will automatically take the size that is compatible with this 3. So what is the size compatible with 3? For this 2, right?
Yes.
Okay, it will automatically take that. So now tell me, if I take here a -1 here and 6 here, so what it will take in place of -1?
6 by 1.
1 by 6, not 1, 6 by 1. Okay, so it will take 1 automatically here. That compatible size it will take. Okay, see that 1, 2, 3, 4, 5, 6. So this is the two-dimensional array which is of size 1 by 6. But if you want to, you see that this is only one array present in this, right? Two-dimensional array. So if you just want to make it as a one-dimensional array only, right? It means you just want to remove that extra bracket. Then you can call this np.squeeze, which removes that extra bracket that you don't want. np.squeeze. Now you see, okay, we'll make it a separate. See the difference. That extra bracket has been removed, right? Has been removed. So yeah, so that is about the shape and the reshape. Now I will show you how to how to access the elements of this list. Okay, sorry, NumPy arrays. I'm taking B here. Okay, so this is B. Suppose I just want to repeat the loop over each and every element of this B. I just want to repeat the loop over each and every element of this B. I just want to access 1, 0, 3, 4, 5. Right. So for each element belongs to this B, what I'm saying, just print B, print this element. Okay. So now you see this. So it repeat it over all the elements of B and it just takes that element and prints it. Okay. So now we see that 1, 0, 3, 4, 5 are printed. Okay. Now let us take C. Can you guess that what should I write if I have to repeat it over all the elements of this C? 1, 2, 3, 4, 5, 6. What should I write here? Can you suggest for loop for this? Hello guys. What should I write? For each 1D array? Yeah, for each element or for each 1D array in C. Okay. And another loop I have to write, right, to access the elements. For each element present in 1D array, okay, print element. 1, 2, 3, 4, 5, 6. Got it? So if I have to repeat it over all the elements of D, then how many loops should I have to write? 1 loop, 2 loop, 3 loop. What should I write? This is three-dimensional array, right? How many loops I have to write?
3 loops.
3 loops. Can you tell me? For each 2D array in D and for each 1D array in 2D array. Tell me next. For each element in 1D array, print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on. Got it?
Yes, yes.
Yeah. There is another way of doing this. Okay, you need not write these many loops. There is something called ND iterator. Okay, ND iterator. Let us take two-dimensional array. ND iterator. Okay, which iterates it over all the elements. Okay, you need not write multiple loops. So you can write a single loop only for each element present in this ND iterator. What is that? C dot ND iterator. Okay, no, not C dot. NumPy dot ND iterator over C. Okay, print the element. Just repeating it over all the elements, right? So which is same as writing 2 loops. Similarly, you can do the same for the 3-dimensional arrays also, 4-dimensional arrays also, whatever that you want. Wherever you want. Okay. So there is another loop which also passes the index values along with the elements. Okay, so the index locations, that is nd enumerate. nd enumerate. nd enumerate of C. Now you see that along with this values, it is also printing you the index numbers, right? So if you want, you can just take another variable, index and element, print both of them individually. Let's see that 0, 0, 1, 0, 1. So I mean, second element is at the value 2 is at the location of 0, 1, 3 is at location of 0, 2, and so forth. Okay, got it? nd enumerate, nd iterate.
Yes.
So we'll see how to concatenate multiple elements, how to combine multiple elements, multiple numpy arrays. So I'm just taking two things here. A is a numpy dot array of 1, 2, 3, and let's take p equivalent to np dot array of 4, 5, 6. Okay. What is it doing? A plus b. What is it doing?
Adding the elements.
Adding these two vectors, right? Or two matrices, a plus b. Okay. Minus b, all that you can use. Okay. But this is not what I wanted to demonstrate for now. So here you can call np dot concatenate. np dot concatenate of a comma b. Okay. Then it will just merges this. See, A is this, B is this, 1, 2, 3, 4, 5, 6. Now, after concatenation, it is merging them into a single numpy array 1, 2, 3, 4, 5, 6. Right. So, there are multiple ways that one can think of this, right? Like, for example, you take this only and let me just call np dot stack. Okay, np dot stack. So this A and B individually. Now I just want to stack them together. Okay. I'm just calling here np dot stack. Okay. np dot stack A comma B. Okay. You need to pass them. So stacking them together, right? 1, 2, 3, 4, 5, 6. One row after the other row, right? So even if you specify access equivalent to 0, then it will be the same. Okay. So by default, access is 0. Suppose if you mention axis equivalent to 1, it means you want to put them in a different direction, right? So 1, 4, 2, 5, and 5, 6. This is how it is stacking them, right? 1, 4, 2, 5, and 5, 6. Okay. This is how it is stacking them, axis equivalent to 1. Okay. There are other functions also. You can have np.concatenate, np.concatenate of axis equivalent to 0, let's say. Right, then it is stacking them like this 1, 2, 3, 4, 5, 6, one after the other. Suppose if you specify axis equivalent to 1 here, now it is stacking them. Okay, this is only 1 day access, right? Index out of bounds, yes. All right. Yeah, for this it is only 1, but we'll see the other one for 2-dimensional array. We'll see again. This is np.concatenate. There are other things also. head stack, horizontal stacking, vertical stacking, depth-wise stacking. Okay, so let me show you those also. H stack. I'm calling H stack horizontal stacking of A comma B. Okay, and I will also show you the vertical stacking, V stacking of A comma B. I'll also show you depth-wise stacking. Depth-wise stacking of A comma B. See the difference. Horizontal stacking means it is just equivalent to that concatenation operation that you're doing, right? Then vertical stacking means one row below the other row, right? 1, 2, 3, 4, 5, 6. And depth-wise stacking means you have 1, 4, 2, 5 each element in the from the individual list will be taken as this. So which is equivalent to stacking them with the axis of 1. Okay, so like this you can combine the multiple things. Similarly, in the concatenate also you can specify the axis equal to 0. It means it will just merges then axis equivalent to 1. If it is a two-dimensional array, then it will stack them on vertical basis. Right. So yeah, so like this you can perform this various ways that we can stack this multiple numpy arrays together, right? The next one is this array split operation that we're gonna see. Okay, are you with me so far? Following it?
Yes, sir. Yes.
Yeah. Let me just take some array. I just want to split it into equal parts. Okay. So A is an numpy dot array of, let's say, 6 elements. I'm taking 1, 2, 3, 4, 5, 6. Suppose if I just want to split it into equal parts. So if I split it into 3 parts, how many arrays I will get? If I split it into equal parts, what are the elements that I get in first array, second array, and third array? If I split it into 3 equal parts.
1, 2.
1, 2, 3,
Next
4,
3, 4. Next 5.
and 5, 6, right? So to do this, we call np dot array split. There's a function called array split. Array split. You need to pass the array that you want to split. How many parts you want to make? 3 parts I want to make. So you see that this is 1, 2, 3, 4, and 5, 6. 3 arrays it is written. 1, 2, 3, 4, 5, 6. If I give 2 here, then
1, 2, 3. Next 4, 5, 6.
1, 2, 3, 4, 5, 6. If I give 3 here, then it is 1, 2, 3, 4, 5, 6. Get 2 here, then 1, 2, 3, 4, 5, 6. If I give 3 here, then 1, 2, 3, 4, 5, 6. If I give 6 here, then 6.
One after another.
One element in
Control
each
6.
array.
Yes.
Suppose the number of elements that I specify, I'm not getting equal parts. Let's say I gave 4 here. Is it divisible? 6 is divisible by 4. It's not divisible, right? Right. So it means 1.5, 1.5 I'll get if I divide 6
Yes,
by
yes.
4. Whereas 1.5 element is not possible, right?
Yes.
Right. So in that case, what we'll get is that first few elements will take the seal of 1.5 and the last few elements will take the floor of 1.5. So what is the seal of 1.5?
Sorry.
Seal of 1.5 is 2, right?
Yes,
And
yes.
what is the floor of 1.5?
1.
So the first 2 arrays will be 2 elements each. The last 2 arrays will be 1 element each. So this is how it takes. This is the array. The next one is repeater. What do you want? This is okay. Could you follow? Could you follow or not? I'm very doubtful. So now suppose I just want to access the indices where the certain condition is matching, elements with certain condition is matching. That's why I just want to access the all the even numbers in the NumPy array A. Okay, how do I do that? Okay, so to do this, we have an NumPy.where. So np.where, and you have to specify the condition inside where. So what is the condition? It should be an even number, right? It means a percentile 2 equal to 0, right? So this will return you all these indices where this condition is matching, right? So what are all those indices? 1, 3, 5, right? Where this even condition is matching, right? Hello.
Yes.
Even
Yes,
indices.
sir.
Even indices are this. I mean, even indices means indices where the even element is present, not just the even indices. Okay, even element index, even element index. Okay, so I just want to access those elements directly, right? Then what would I do? I just access a of even element index. Okay, then it will print 2, 4, 6. Right, these are the even elements. So like this, you can specify any condition and then use that condition using np.where, right? Then we often perform some kind of initializations, right? Like we want to initialize the matrix of all zeros, matrix of all ones. This kind of initialization we often require, right? So you can initialize them like np.zeros and mention the size of the array. Let's say 3 by 3. Okay, you can mention 3 comma 3. In the as a tuple, you can mention 3 comma 3. Similarly, if you want a matrix of all ones, nb dot ones, and specify the size inside that 3 comma 3. So you can print both x and y and see that. See that this is the matrix of all zeros, and this is another matrix of all ones. So matrix of all zeros, then matrix of all ones. Okay, if you want, I can give more. Right, this is how you can make initialization. Then the next one is how to perform the matrix operations like multiplication, matrix multiplication, inverse, or if you want to go with the element-wise product, transpose, eigenvalue computation. These are all the general things that we usually perform, right? So let us see how to perform those. Okay. So I'm taking an array, compatible arrays. So I'm taking array A, which is of size 2 by 3. This is 2 by 3. Let us take another array which is of size 3 by 2. 2 by 3 and 3 by 2. Are they compatible for multiplication? Two by 3 and 3 by 2. Are they compatible sizes for matrix multiplication?
Yes, sir. Yes.
Right? So A and B I'm taking here. I just want to take the product of A by B. So what is the resulting matrix size if I multiply 2 by 3 with 3 by 2? 2 by 3 with 3 by 2, if I multiply, what is the resulting matrix size?
21.
2 by 1, 2 by 2, right?
Yes.
2 by 3 and 3 by 2, 2 by 2, right? So A at the rate B we use for this matrix multiplication. A at the rate B. You see that? This is the resulting matrix which is of size 2 by 2, right? There is another way of doing this by calling some function in the NumPy library, that is np dot dot. np dot dot. Passes both A and B. This is also the same. This is also the same. So at the rate B or np dot dot is also same, right? So they're just taking the multiplication that you should have the compatible sizes. right? So if you don't specify the compatible sizes for the multiplication, it will throw an error. Compatible sizes, if you don't mention, it will throw an error. Okay. The next one is transpose. Okay. Transpose, to perform transpose, what we do is that we call matrix name or the numpy array name dot capital T, right? So what is the size of B now? What is the size of B? Size of B, 3 by 2, isn't it?
Yes, sir.
I don't know. It is really boring for me. Nobody is speaking.
No, no, sir. 3 by 3.
3 by 2. Okay. Okay. B transpose will be of size how much?
2
If
by
B is
3.
of size 3 by 2, it will be of size 2 by 3, right? See
Yes.
that. 1, 3, 5, 2, 4, 6. This is the B transpose. Now A is of size 2 by 3. B transpose is of size 2 by 3. Can I take element wise product? Element wise product. They're compatible, right? To perform element wise product. So A np dot multiply we use for the element wise product. You pass both A and B transpose. Okay. So you see this. This is B transpose. The first one, 1, 3, 5, 2, 4, 6 is B transpose. And this is A, 1, 2, 3, 4, 5, 6. When you take the element wise product, 1 is multiplied with 1, you got 1. 3 is multiplied with 2, you got 6. 5 is
5.
multiplied with 3, you got 15, and so on. 6 is multiplied with 6, got 36. So this is NP dot multiply. So what if you want to get some inverse operation or eigenvalue computation? These are the things generally that we use, right? So these are the things that generally we use, finding out inverse eigenvalues and all. So let me take another array. Let's say some x I'm taking. Let me take some two-dimensional array. 1, 3, let's say 5, 6. Okay, so something like this I'm just taking. Okay. So to perform this inverse operation, what we call is that NP dot linear algebra, LEN ALG, LIN ANG. Okay, linear algebra dot inverse INV on this X. So this is the inverse of that. Okay, so X inverse, I'm naming it as X inverse. Right. So when you multiply X with X inverse, what should you get? Hello.
X.
X with X inverse, if you multiply X with
Ide-
X, identity matrix, right?
Identity. Yes, sir. Yes.
So you see that this is identity matrix. You see that these are zeros actually. You may be feeling that it is some number because it is looking like some number, but here you see that e to the power minus 17. It means this is 2.71 to the power minus 17. It's almost close to zero. Similarly here also, e to the power minus 16. This is also very close to zero. I mean almost zero. Zero only. Right. So this is how you compute this inverse operation. Suppose if I want to compute the eigenvalues and eigenvectors. So eigenvalues, eigenvectors, W comma B respectively, you call NP dot linear algebra LIN ALG dot EIG. EIG means eigenvalues and vectors. On X I am calling. You can print both W and V. W is for eigenvalues and V is for eigenvectors. Eigenvalues and eigenvectors. Minus 1.109 and 8.10. These are the eigenvalues. And the rows that you see in that second vector is the eigenvectors. Right. So this is how you can compute the eigenvalues and eigenvectors using the NumPy library. Not only that, you can even take the minimum, maximum, row wise, column wise, all that can be done. Okay. So here I'm just printing B for your reference. So if I take minimum, okay. So minimum, maximum, row wise or the column wise, you can perform. Okay. So like for example, I'm taking here 3 dot minimum, and access time that is specifying is 0. Okay. Then you see that it has got 1 and 2. Means it is giving you the row wise minimum. Okay. So if I specify access equivalent to 1, it will, it is giving you the column wise minimum here, 1 and 2. So 1 is minimum in the first column, 2 is minimum in the second column. Similarly, if you specify access equivalent to 1 here, it will give you row wise minimum. So 1 is minimum in the row of 1, 2, 3 is minimum in the row of 3, 4, and 5 is minimum in the row of 5, 6. Okay, that's how even you can do the maximum, average, sum, all that can be done using this various built-in functions available for NumPy. So the next one is line spacing. This is also one of the things that we often use. Okay, line spacing option is generating numbers with equal line space between them. So the function for this is that space line space. Okay, you have to specify the starting value, ending value, and how many numbers you want to generate. Right. So 9 numbers, let's say. It means it is starting at 0, ending at 20, and in between that, with equal line space, it creates 9 numbers. You see that starting at 0.
ఏ సంతోష్
Starting at
ఇందాక
0,
బయట చూసాను
ending
సార్
at
నేను
20, right? And then giving you 9 numbers with equal line space, starting from 0 to 20. So if I give 10 here, then it will generate 10 numbers with equal line space. If I give 11 here, then it will generate 11 numbers with equal line space, right? So this is about the line space and how it works. And there is something called arrange in NumPy. I'll show you the output. You need to just tell me.
నేను ఎన్ఐటికి
You just have to tell me that how is it? What it is doing. Okay. So let me just take np dot arrange.
నేను ఒకసారి చూసి చెప్తాను డేట్
np dot arrange. I'll directly print. You will return that. I'm just direct. Okay, so you have to specify starting index, ending index, and the step size. Okay, so it means it starts at 0 every time it adds 6 to the starting element, and then it repeats over till it exceeds this 20. So starting at 0, 0 plus 6, it is 6, 6 plus 6, that is 12, 12 plus 6, that is 18, and so forth. Right, so understood, right? The difference between arrange and the line space. Got it?
Yes, sir.
The next library is Pandas library. If you want to install this, pip install space pandas. Okay, so the pandas are used to analyze the data as well as clean the data. So there are two things in the pandas framework. One is data frame and data series. Data series can be visualized like a one column in the table, and data frame can be visualized like multiple columns in the data frame, right? Data frame is the multiple columns in the table, right? So whereas data series is a single column in the table, that kind of thing. So here I'm creating one data frame now. I can also create data series. I'll show you data series first. So let's say that I just want to create a column of all 1, 2, 3 like that. 1, 2, 3, let's say. Okay, so I'm just creating data series equivalent to pandas pd dot
రిపోర్టింగ్
series
ఆన్లైన్ అన్నారు కానీ
pandas dot series, and what you want to
Holiday
convert that
ఉంటుంది
into
first
series
ఇప్పుడు.
a, right? So you can just print the
థర్డ్
data
హాలిడే
series.
ఉన్నట్టున్నాయి రెండు బోనాలు కాదు వేరేది అనుకున్నా
You
సాటర్డే
see that?
ఏదో వచ్చింది
Okay,
ఏదో
I didn't import this.
సార్ ఇంతకుముందు ఆగస్ట్ ఫస్ట్ ఏదో చూసినట్టు గుర్తు అయితే నాకు కరెక్ట్గా గుర్తులేదు
You see that it is creating a series of 1, 2, 3. Okay, creating a series of 1, 2, 3, and these are the index numbers 0, 1, 2. If you want, even give the column head also. Okay, if you want to specify the column titles also, you can specify. Okay. And we'll see another one. how to create a data frame. So here I'm taking a student information, like what is the name of the students and the branches. Okay. So this is the table that I want to create. So I'm just taking data as a hash, data equivalent to some. So I'm just giving two columns. One column is name, the other column is branch. Name of a student and a branch of a student. So these are the names of students. Ramu, let's say give some names and lines and names. So and let us give another Kam. So these are the three names, and we also have to give the corresponding what else that we thought of representing branch. Okay, so this is the branch. I'm giving another name branch, which is another column that I'm planning to give. So you can say some PhD, some triple E, PC. So these are the branches. With this, I just want to create a column, a table of two columns, right? So you can create a data frame equal to pandas.data frame, and you can pass the data to it. Okay, so that's all. We have created the data frame, and let me just print and show that to you. So this is yeah. So this is like this, right? Name and branch. It's like a table, isn't it? It's also giving the index numbers 0, 1, 2, and so on. But if you want to specify your own indices, like for example, I just want to take the student roll number as the index. Okay, that is possible. So you can take the again same thing. Okay, you can have this facility to specify the index numbers, right? Index numbers or index values. Okay, so here the index that I am passing here is this. Next that I'm passing is, let's say I just want to pass some names like X, Y, Z. Now you print df, and now you see that the index names are X, Y, Z, right? So this is how you can create your own indices. You can give your own indices. Okay. So let me take this data frame again and show you a few operations that we can perform. Okay. So again, I'm taking this data frame df. This is it. So this is the data frame. Okay. Suppose I just want to access the name information of each and every student. Okay. To access the name information, we call df.name. Name is the column name, as you observe there, right? Then it will only give you the column names, Ramu, Somu, Kamu, as you see there. So now, can you tell me uh, how to access only this branch information? Branch information. Hello.
Branch.
Dot branch.
Yes.
Okay. So it gives you only branching information, as you see there. So suppose if you want, there is another way of doing this. Like you can even give df of branch, of name or of branch. So this way you can have multiple values also. Okay, I'm just giving this name here. Then it will also just access that first one. So if you want just to give multiple values, right? I mean multiple columns you want to access, then you can specify the list of those columns. So here, let's say I just want to access both name and branch at a time. Okay. So you can give name branch also here, name comma branch in a list. You can specify. You see that that is accessing both name and branch simultaneously. Okay. So this is one way that you can access this columns, right? I'll also show you. Suppose I just want to get the information about the df1 I'm here. I just want to get the information of uh, different students individually. Like for example, I just want to access 0th student information. What is his name? What is his branch? Okay. So to do that, we have a df1 dot location of 0. Okay. Then now you see that at 0th location, we have a student named Ramu and branch is CSC. Suppose if I am to access the SOMU details, then what should be the index number that I have to specify here? SOMU detail. I have to specify the index number 1 here. You see that? Okay. Suppose I just want the branch information of SOMU. I don't want his name, right? So df1 dot location of 1 dot branch. Okay. Then it will be able to access only the branch information of SOMU, which is triple E there. All right. So like that you can access it. Okay. Access the elements. And there is another one. We have the provision of giving our own index values or the index names, right? And we have also given here also XYZ. Okay, how to access here? Suppose if I just want to access SOMU details, what should be the index value that I should pass? SOMU details. df dot location. And what is the index value here?
Once.
For SOMU. What is the index value?
Once. One.
1 or y? You see
Yeah,
that column?
yeah. One. Wise.
Y. Okay, you want branch details of him, you can call branch. Triple. Right. Like this, you can access the values. I mean, by specifying the index values. Okay. So like this, you can access. There is a way of reading it from the files also. I can show you how the file looks like. Okay. So these are the files I will share with you later. Okay, sample 2, sample 3, and students. These are the files that we're gonna use. Okay, this is an Excel file. To read an Excel file, we use read Excel from the Pandas framework. This is the student information again. There are 4 columns: ID of the student, name of the student, branch of the student, and age of the student. So these are the 4 columns. So let us see how to read it. So to read this, we have in the Pandas framework, read underscore Excel and specify the file name. Okay. So if you are doing it in a Google Colab, you just have to first upload this file. Okay. So you just check how to upload a file in the Google Colab. You will get some 2-line statement. You just have to execute the 2-line statement before you call this function, right? So sample2.xls is the file name. I'm just reading this, and this returns the data, okay, or the data frame it returns. Okay, so data frame 1, I'm just naming it as a data frame 1. So this returns the data frame. Let me just show you how this data looks like. Data frame 1, you see that this is the first one is the index number 0 to 5, ID values 1 to 6, name are Sanya, Narayana, Venkat, Durga, so on. Branch, these are the branches, and age is this, right? So like this, you can directly read it from the files also. So here we have a very simple file in which we have only got 6 records. but in real-time data sets when you're loading especially, there are maybe lakhs of records, right? If you print them, all of them, it's very, I mean, looks clumsy and it's not possible to accommodate them, right? Right. I mean, it looks a really longer space and time to print them, right? So if I just want to check how the file is looking, what is the format of it, how many columns are there, all that, we have some function called df.head, df1.head. You can even specify the number of rows that you want. If you give 3 here, it will just, uh, if you don't give anything, by default, I think it's 5. If you give 3, it will just print the first 3 records. You see that? It is just printing the first 3 records. Similarly, can you guess if I just want to print the last few records? What should I give instead of head here?
Tail.
Tail of 3. Okay, you see that the last 3 records it is printing. So if you just want to give the information, get the information about each and every attribute individually. It means how many non-null values are there, how many values are there, how many unique values are there. So this kind of information, suppose if you want to get, there is something called info. Okay, so df.info, df1.info. You need not specify any number here, right? So here you see that it is giving information about each and every column: ID, name, branch, and age. 6 non-null, what data type it is, how many columns are there, how many non-null values are there. All right, like that you can see the information about each and every attribute by calling dataframe.info. Okay. Okay. Suppose here I just want to get the information of different students' name and their ages. Okay. How do I get that? Any guess? Name and ages I want to get. Let me print this for you again. df1 I'm printing. I just want to access name and the age of different students. How do I do that? df1. What should I write? Name and age I want to access. Name and age. Hello, anyone? What should I write if I have to access both name and age? In the bracket, I have to specify the name as well as
Yes.
age. Name and age. Okay, so this will just access the name and age columns. Something. I have to specify that as a list actually. Name and age, as you see here. Okay, suppose I just want to access the name and age of the alternative students, not every student. Okay, you have an option to do that here. You can specify all the students, or you can start with 0 index and at 6th index. Okay, and I want to access the alternative subset. Name and age of student 0, 2, and 4. Okay, if I specify the step size 3 here, then what it will print?
03.
0, 3, that's all, right? Right. So like this, you can access the multiple columns or the multiple rows simultaneously by specifying the step size also, you can go through it. Suppose I just want to get the information about all the students whose age is less than 20, okay, or less than or equal to 20. Look at the table and tell me who are the students with age less than or equal to 20. What should it return if I write a query saying that I want all the students with age less than or equal to 20. Who are they?
Venkat Durga Saran.
Venkat Durga Saranya. Okay, not one name, multiple names. Okay, so let me just print again. So this, okay. Oh, df1 I gave. What is it? Yeah, df. Okay, fine. So now we just want the indices where
Yes.
this certain condition is matched. What is the condition? The age
Yes.
should be less than or equal to 20.
Yes.
So df1 dot age must be less than or equal to 20. This is the condition. Okay, this is the condition. df1 dot age less than or equal to 20, and this will return the indices. Okay, you see that. These are the indices where false and true happens, right? So age less than or equal to 20, false, false, true, 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 false. Okay, it means it is giving you the indices where this condition happens. I mean, where the condition is true. So now I can directly call df dot location and pass these index numbers. Okay, so these index numbers I'm just passing. Okay, I can even store this in some index. Okay, index. These are the indices. I can just print you that indices. Those indices. We can write the whole thing in a single line also. Okay, just to give a clarity, I am writing in multiple lines. Okay. Now, okay, directly. Refer to this index. Okay, so df dot location and specify this index. Okay, specify this index. Okay. Uh,
DF1.
okay. So what did you get?
Yes.
All the
Yes.
student records whose age less than or equal to 20, right? Okay. So you can directly also give this. Like instead of writing two steps, you can directly, instead of giving index here, you can directly specify this here. Okay, this will also work. So it means this returns the indices where this condition matches, and you're just accessing those indices, records at those indices at those locations. Okay. Okay. So similarly, can you write a code to access all the students belong to CSE branch? What should you write?
DF1 dot
If one
branch
dot branch equal to
is
CSE. Yeah. So like that you can mention. So this is the accessing the records. Similarly, you can sort them, sort the records based on a particular attribute. Like for example, if I want to sort this students according to their ages. Okay, so you can call df1 dot sort values, sort underscore values. Specify the attribute based on which you want to sort. Okay, age is the attribute, right? Here. So I'm just sorting them. You see that the student records are sorted according to their ages. Suppose if you just want to sort them in the descending order of their ages, right? Then you can set the ascending equal to true. Ascending
గుడ్ మార్నింగ్
equal to true.
మ్యామ్. ఫస్ట్
Sorry,
ఇయర్ ఒకసారి
false.
స్టూడెంట్
By
లిస్ట్
default, it is true. If you want them in the descending order, set the ascending
ఫస్ట్
equal
ఇయర్
to
ఇప్పుడు
false.
ఫస్ట్ ఇయర్ వాళ్ళకి డేటా
Now you
పంపిస్తా
see that
ఒకసారి
it is
డీటెయిల్స్
returning them in the
ఫైల్ నెంబర్
descending
వాట్సాప్లో
order,
పెడతారా?
right? 22, 22, 21. All right. So like this, you can sort the elements.
హలో
Suppose if your file is a .csv
హలో
file, you can read them like this. df2, let's take, okay, pd dot read csv, read underscore csv, and specify the file name. If it is in the same folder, you can directly give the file name .csv. If it is in the different folder, you have to specify either the relative path or the full path, complete path. Okay. Now I'll demonstrate some more sample such file. So if it is, I'll also demonstrate some more things like how to drop the duplicate rows and how to fill the NaN values, right? These are the general things that we require, right? So let me demonstrate them as well. So for that, let us take a different file here. Students.x. I'll share you all these files and also files and this Python file also I will share. So pd.read Excel I'm doing here. I'm specifying students.excel, which is the file name. I'll show you how the file looks like. How the data looks like. You can print this df3. As you see here, this is how the data looks like. There are seven columns: ID, name, branch, age, subject 1 marks, subject 2 marks, and subject 3 marks. Right. So these are the different things available, different columns available, attributes available. Okay. So now suppose if you observe this, there are some duplicate entries, as you see here. So what are the duplicate entries? Index number 7 and index number 10 are duplicate. See that 106 Bala, CSC 22, 78, 79.0, 54. All of them are same, right? So these two are the duplicate rows. Okay. So if you want to remove the duplicate rows, there is a function called drop duplicates. Okay. So df dot drop underscore duplicates. Okay. So this will just return the data after removing the duplicates. Okay. df3 dot drop underscore duplicates. This will return the data after removing the duplicates, but it will not make any changes to the original df3. So if you want to make it changes to the df3, you can replace it with this, or there is another way also. I will show you that, but before that, let me just print this. df3 dot drop duplicates. Okay, you see that now the duplicate record has been removed, right? The last one. Could you observe that? Could you notice that? This
Yes,
last
sir.
one that has been removed,
Yes, sir.
right?
Yes.
But now let me just print df3 after this. Okay, let me just print df3 again after this. You will observe that it will not make any changes to the original df3. You see that it is still there in original df3, right? So suppose if I just make here in place equal to true, it means it is making changes to that df3 itself. Whatever the changes, it is making in place. Then it will not return anything. Now, like it is returning the updated one, but now it will not return anything. Instead, it will make changes to df3 itself. It will return none. You see that it is returning none, as you see here. And now it is updated. df3 is updated, right? The duplicate record has been removed. So this is how you can drop the duplicates. The next one is how to drop the NaN values. Like you see that there is a record with some NaN value here. Either there are multiple ways of handling these NaN values. Either you can drop them, or you can fill them with some default value, or you can fill them with some strategic number like average of that column or so on. Right? You can fill it in multiple ways. Right? So let us see multiple ways how to drop this NaN values. Right? So this is also the same. If you don't set in place equivalent to true, what happens if you don't set in place equal to true? It will just return, but it will not make any changes to the original data frame. So let us just print this df3 dot drop na. Okay, df3 dot drop na. Drop na. Okay, and pass this. You need not pass anything. If you have to pass, but if you want it to be in place, that we will see later. Okay, now you see that NaN value is dropped out. You see that now you don't find any NaN value, isn't it? Hello?
Yes, sir. Yes.
Right. So that is dropped, but it will not make any changes to the original data frame. If you want it make two changes to the original frame, you have to set in place equal to true. But I'm not executing this right now because I just want to show you the different ways of handling this NaN values, like filling it with some default value and so forth. But you can set in place equal to true. Fine. So now suppose I just want to replace it with some default value, let's say 100. Fill it with some default value, right? So where NAN is present, in which column? Here. In which column? In which attribute? S2, right?
Yes,
Isn't
yes.
it? So you just access that. Okay. How to access that? df3.s2 dot fill NA. Okay, and give the value that you want to fill. Okay, so this will fill with 100. You see that it is filled with 100, right? Right. But this will not make any changes to the original data frame. If you wanted to make changes to the original data frame, you have to do this. Okay, I'm not executing this, but you can do this later. df3.s2 equal to this one. Okay, it means this is replaced. The existing df3.s2 is replaced with updated df3.s2. Updated wala is filled with 100 wherever NaN value is present. Got it? Could you follow
Yes,
it?
sir. Yes, sir. Yes,
Yeah,
sir.
yeah. So you can even fill it with something like the average of that column. Like that you can fill, right? So if I want to fill it with the average of that column, again the same thing, df3.s2 dot fill NA, till here it is common. So instead of filling it with 100, we want to fill it with the mean value of that column, right? So to get the mean value, we call df3.s2 again dot mean. Okay, so mean value, mean function you can call, it will replace it with the mean value of that column. You see that now it is replaced with 75.66, which is the mean value of that. Okay, if you want, you can print both. Whatever that it is returning. You see that the first one is replacing with 100, the second one is replacing it with 75.66, which is the average of that column. All right. So now tell me how to fill the multiple columns at a time. Like for example, if there are multiple values at multiple NaN values at multiple columns. If you want to fill all of them at a time, then you can pass a list of those columns here. Okay. So the list of those columns, like I can say S1, S2, so on, S1, comma. Actually, we don't have them in our example, but you can try in the example. You can set them to NaN and try which is, I mean, dot fill NaN. Okay. Okay. Similarly, you can also mention mean here also, all at a time. df3 dot all this dot mean. Okay. You see that this is replaced with 100. Wherever NaN is there, that is replaced with 100. Okay. So like this, you can fill NaN values of the multiple columns at a time. So is that clear so far?
Yes, sir.
So we have discussed the two libraries, NumPy and Pandas. NumPy is for the vectorized numerical computations, in which we have seen multiple things like how to perform how to create arrays, one-dimensional, two-dimensional, three-dimensional, four-dimensional, and so forth. How to access the arrays and how to perform different operations like matrix multiplication, matrix transpose, matrix inverse, matrix finding out the eigenvalues and so forth, different matrix multiplication things, matrix related operations also we have seen. And we've also seen how to make the initialization, how to access the elements in the NumPy arrays, and so forth. A lot of things we have seen in the NumPy arrays. Then we started discussing the pandas. Pandas is for basically analyzing the data. It is used for the visualization also, that I'm going to show you. And then we have also seen how to clean the data, how to fill NaN values, how to drop the duplicates, how to sort the values. So multiple things we have seen using the Pandas framework. So I hope both the things are clear to you. NumPys and Pandas, how to import them, how to use them.
Yes, sir.
Yeah. So now I'll show you the data visualization. So as it takes a longer time and we left with only 15 minutes, so I am just going through it, and this file I will share it with you. You can practice it later. Okay, I'm not typing it. Fine. So we're gonna use this matplotlib.pyplot for the for the visualization purpose, and there are other libraries also, SNS, Seaborn library, and you can also use the Pandas library for the visualization. I'll show you all of them one by one. So here are the required libraries that I've imported. So this is the important one that we are going to demonstrate, matplot, lib.pyplot. I'm just naming it as a PL, plotting purpose. So I'll show you how to create the curves first of all, curve plotting. Okay, so curves like this. We often require these kind of things, right, to present the results, right? So here there are two axes, x and y axis, right? So I'm generating x axis values randomly, not randomly, using the line space. I'm generating 50 numbers in the range of 0 to 5 with equal line space. I'm generating um, 50 numbers in the range of 0 to 5 with equal line spacing. And y value, I'm taking two different y values. One is the cos function I'm applying for these x values. I'll get the corresponding y value, y cos I'm naming it as. I'm calling np.sine and passing this x value. The corresponding y value is y sine. Now I'm just calling plt.plot. Plt.plot is the function we use for the plot curving. Pass both x and y axis. X is this, y cos is this. And similarly, I am plotting another one, x comma y sine. These are the labels that I am giving. plt.x label. I'm just giving a label called x. Y label, I am giving it as a y. And this is the title that I am giving, sine and cos curves. Okay, so let me just execute this. Now you see that, you see this. This is what the curve that we have got. So the x-axis title, we have got it as x. And y-axis title, we got it as a y. And the title of the figure is sine and cos curves. That's what we get. X label is x, y label is y, title is sine and cos curves. And here you got two different curves. The blue curve indicates the cos curve, and this orange color curve indicates the sine curve. And if you want, you can specify your own colors also. The colors that you want and the line styles that you want, you can specify there. Okay, that we see as we proceed. Okay, so like for example, here I want to give some red color. You can specify the red color. Suppose if you want to give the dotted lines, then you can give the double dash here. Then you see that it is printing you here the that cos curve with this red color dotted lines. Like this, you can customize, and you can even customize the line width also by specifying the width, line underscore width equivalent to some point you can specify. You will be customizing it. Okay. Similarly, you can have the points also. Like for example, here itself, let me just plot it. Okay, I'm just plotting plt.scatter of x comma y sine. Okay, then it will present them like a points, not like a curse. Scatter. You see that here. Okay. It's like points, right? 50 points with equal line space, right? So like this, you can use this scatter to scatter the data points. Okay. So here is another example for the scatter. X equal to np.random.random. This is randomly generating 100 numbers using the normal distribution. Random means random number. Normal distribution. Random means random number. This is in the NumPy library. We're randomly generating 100 values using this normal distribution. And y cos I am calling np.cos of x, plt.scatter I am doing this. You see that this is how the points are distributed, right, according to the normal distribution, right? And we applied a y cos. This is to demonstrate the scatter. Okay. Demonstrate the scatter. Let me just see. Right. So this is one. The next one is how to use the panels. Most often, in many of the figures, we often want to plot the subplots. Like we don't want them. Suppose if you don't want to give the sine and cos curves in the same figure. Okay, sine and cos curves in the same figure. Instead, I just want to give them in two different graphs, subgraphs or subplots. Okay, so like this. Like this, I want to give. Then how do you do that? Okay, that's what the panel is doing. So here again, I'm creating the same data. X equal to np.line space of this y cos y sine. but I'm just plotting them in two different curves. Okay, here. So for the subplot, if you want to have a subplot, then we call the plt dot subplot. Adab, could you follow it? Am I going too fast? Could you
Yes.
follow it or not?
Following.
You want me to follow it? Okay. So plt dot subplot, and this 2 by 2 is the grid size. Okay. So suppose if I mention 1 by 2 here, it will take two grids in one row and two columns. And this particular plot I am placing it in the first location. Okay. The y cos and indicated with the red color dashed line, and title is cos. And the second subplot, okay, this is also in the 1 by 2 grid. It is at the second location, let's say. Okay. And this is indicated with a blue color solid line, sine curve. Now you see that when I execute this, this is what I get. This is a 1 by 2 grid. So in the first location, we have got the sine curve, cos curve. In the second location, we've got the sine curve. Okay. Suppose if I mention it as a 2 by 1 grid instead of 1 by 2 grid, it means two rows and one column. 2 rows and one column. 2 by 1. Okay. So now it is coming like this, as you see here, right? One below the other. All right. So suppose if I give 4 by 4, I mean 2 by 2, it means 4 entries are there. At the first location, I want to place this cos, and at the last location, let's say I just want to place this cos curve. At last location means 4. Then it will come like this. Right. So first location is this, second is this, third is this, and fourth is this. Okay. Understood? Subplotting? Understood or not? How to make subplotting?
Yes.
See, clear. So there are various options actually. You can change the colors, you can change the markers, line styles, you can even change the line width. All that are possible. I gave some references here for further personalizations. So if you want to change the line colors, line markers, line width, all this you can go through here. You can make the personalization according to your requirements. Okay. Then if you want some plot like this, so what is the plot? Here there are 3 different groups: group 0, group 1, group 2, and each member belongs to a particular group indicated with a particular color and a particular style. Like we have the yellow squares here indicating group 0, and blue color stars here indicating group 1, and red color diamonds here indicating group 2, and so forth. Suppose if you want something like this, okay, how do we do that? All right. So let me explain this. For this, we are taking a data set, make blobs data set. It is to create a blobs kind of data. So there are 3 blobs in this, right? So this is blob 1, blob 2, blob 3. 3 sentence, 3 blobs we are creating. Acha, by the way, I have to explain one more point here. sklearn.datasets. This sklearn is a very useful library for this implementation of the machine learning related algorithms. Okay. So you can type sklearn in the Google and click on very first link, sklearn.org. You will see this library, very well documented. These are the various algorithms, classification, regression, clustering, like this various algorithms are there. And if you want to implement a particular algorithm, let's say SVM, you can click on this SVM. It is very well documented, the whole explanation about the SVM and how to implement SVM with an example also given here. Very well documented, you can take it there. Not only that, it has the methods or the techniques, algorithms. It also has got data sets. It has also got evaluation metrics. It has also got the pre-processing techniques. So all the pre-processing techniques are present at sklearn.preprocessing. All the data sets are present at sklearn.datasets. Okay, and all the evaluation metrics are present at sklearn.metrics. So if you just want to see what are the data sets available and what are the evaluation metrics available, you can type sklearn.metrics in Google and click on very first link. Okay, then you will see the different evaluation metrics here. Could you see my screen, by the way?
Yes, sir.
Yeah, these are the evaluation metrics relevant to classification. These are the evaluation metrics relevant to clustering, and these are the evaluation metrics relevant to regression. Similarly, the data set. Suppose if you want to see what are the data sets that are present, you can type sklearn.datasets in the Google. Click on very first link. You will see the different data sets. These are the toy data sets, but there are toy data sets are to play with the written code. But if you want to apply it on some real-time data sets, you can have the real-world data sets here. These are the data sets: Olivetti faces data set, continuous group data set, like this various real-time data sets available, right? And the description of them also available here. You can just import them and use them. Okay, that's all. And I can show you that. Is it that Python classes are the beginning classes, or have you been covered with any machine learning related algorithms? Any algorithms were covered, like regression or classification, anything like that?
No, sir.
No, no. Okay. Okay, fine then. Better not to touch that part now. Okay. Or I will show, if I have time, I will show how to fit linear regression model or something. Okay. Because you don't have idea about problem, all of you. So that's why better not touch that, but you can explore that library later. Acha, coming back to this. So to generate the data set, we have imported this make blocks. We are generating 100 data points with number of features equal to 2, number of centers equal to 3. Random state, I'm just fixing because every one of us will get the same random data, right? If you fix the random state, because it's a demonstration, I've just fixed it. So here the class labels are the group values you are accessing by calling data set of 1. This is the y values. Data set of 0 will give you the coordinates of the points. Okay. So for each group I am plotting here. For each group, okay. So I'm just taking group wise, y equal to 0, right? It means the group number and the corresponding 0th coordinate group, I mean indices. What are the indices, right? And the corresponding column. So this basically actually what you're doing here is this is giving you the index numbers. This is giving you the, give me a second. Sorry for that. So these are the row numbers. Actually, row numbers where group 0 is present, right? Instances from group 0 is present. And this is the column number. It means you're accessing the first feature value. And these are the instances and the corresponding value. I mean, the column number 1. It means this is the coordinate 0, coordinate 1, right? For all those instances belong to group 0. And you're indicating them with yellow color squares. The first letter signifies for the color, second letter for the shape, yellow squares. And we are just labeling them as a group 0. Similarly, we are repeating the process for group 1 and group 2. Group 1 values are indicated with magenta stars, magenta color stars, and red color diamonds are used for the group 2. Okay, so let us just execute this and see this. Okay, what's going on? Where is this figure? Yeah, here it is. So yellow squares, red color stars, magenta stars, red color diamonds. And this is the legend that we have placed here on the lower left corner. To place the legend at a particular position, we have a plt.legend. You can specify the location. I specified lower left. Okay, and the number of points in the legend is 1. Suppose if you see 2 here, Then you get a two points at group 0, 2 squares, 2 stars, 2 diamonds here. So if I just give 1 here, number of points equivalent to 1, then it will just give 1 point in each of this. So 1 star, 1 diamond, and 1 square, like that. Okay. So, and even you can annotate it, like for example, here I annotate the squares, stars, diamonds here, right? Some string values I've given, annotations. So you can call plt.annotate. You can specify the string that you want to annotate and the location of it. Minus 10 comma 2, this is the location. So this is the location, minus 10 comma 2. I just want to place the string squares. Similarly here 0 comma some 2, I just placed this stars, and 8 comma 4, I just placed the diamonds. Like this you can specify the location and you can annotate with the appropriate string. Then histograms. This something like this. Okay, you can have them by calling plt.hist. plt.hist, np.column stack. These two. This is the random values that I'm generating using the normal distribution, np.random.rand. This is the location, which is the mean value, and this is the scale, which is the standard deviation value. And the number of points I want to generate is 500. And coming to this histogram, you can plot the histogram of multiple variables at a time. So that's why I'm just plotting them in a column stack, np.column stack. I'm putting x and z in a column stack. Number of bins I'm generating is 15. Histogram type I'm taking is a bar. There are various other things also, like this type, various options for the histogram type. Step, bar, stack, like that. There are various options. You can explore them. Colors I'm giving is cyan and blue. Cyan for the first one, for this x, blue for the second one, for the z. Okay. I set stack equal
Orange
to
color or
true.
something.
Okay, so it looks something like this. I set the Seaborn to true last time, but otherwise it looks something like this. This is with 0 mean, this is with the mean of 6. Alright. So like this you can have the histograms. Then the bar plots, something like this if you want. Bar plot something like this. Then you can have a plt.bar. Specify the x and y values. Width also you can specify. Here I didn't specify any width. Width I have specified it to be 0.2. But if you want, you can specify. You can customize this. And color, I'm giving different colors for 3 different values: y1, y2, and y3. Right. And this is the location where I want to place x minus 0.2, x, and x plus 0.2. Okay. So this is the bar plot. And if you want the bar graphs, something like this, horizontal bar graphs, vertical bar graphs, something like this, that is also possible. Let me just execute this as well. Okay, so here you see that here we have used the iris dataset. From sklearn datasets, I've imported iris dataset. I'm just loading it. Iris dataset, some of you may be having idea about it. Iris dataset is a flower dataset in which we have 3 flowers: Iris setosa, Iris versicolor, and Iris virginica. And each of the flower is described using 4 features. 4 features are the sepal length, sepal width, petal length, petal width. So suppose if you want to summarize the data using the attribute wise summarization, if you want to give, you can go with this bar graphs. If you want to give the horizontal bars, you give the bar h. If you want to give the vertical bars, you just give bar, right? And this is the range, and I mean we want to give the average value and the standard deviation value to get this lines, right? This is the plus or minus the standard deviation value, that black color line that you see, right? And this is the column names that you're giving: sepal length, sepal width, petal length, petal width. So you can give the horizontal bars also. If you want to get this rotation, you have to set the rotation. So in the Xtix, you set the rotation to 45 degrees. Then if you set the rotation to 30 degrees, then that rotation will be 30 degrees, as you see here, right? So like this, you can plot this graphs like this using the bar h and bar. Okay, so you can even show the faces like this. If you want to show the faces from the feature vector, that is also possible. So here, for this purpose, I am importing Bima sir. Do you have any query?
No, sir. No, sir.
Yeah. Okay, sklearn.datasets, I'm importing fetch Olivetti faces. This is a real-time dataset for the face recognition problem. I'm just shuffling them. I just calling and by setting the shuffle equal to true. Randomly I'm picking these faces. This is the data set. I'm just showing you the first few faces. Okay. So first 6 phases, x equal in the range of 0 to 6. So subplot I'm creating 2 by 3 grid, 2 by 3 grid like this. Okay. And I'm just calling this each data set dot data of k. It means it is accessing the feature vector, which is of size some 64 times 64. Now I'm just reshaping it in the size of 64 by 64. And then color map is gray, interpolation is set to nearest. I am calling imshow function. This will show that in that particular location specified here. So initially k plus 1 is 1, then 2, 3, 4, 5, 6 locations. Okay. So set the axis is off. If you don't set the axis is off, then it will show the axis values also. It creates a disturbance. I have create title here. So phase number, the data set the target value I have accessed and I have appended that to phase. Right. So phase 21, 19, 11, target value. That number is target value. So this is how you can show the images also. Similarly, you can see the another one later. You can go through it. And this is the I said no that we can even use the pandas for the visualization purpose. So here is we are using pandas. Okay. So data frame dot box plot you can give. This is giving you the box plot. If you have no clue about the box plot is the 5-number summary of the data set. So it summarizes the data using the 5 numbers: minimum, maximum, median, lower quartile, and upper quartile. So this is the minimum value, this is the maximum value, and the green curve is the median value. Lower end of the box is the lower quartile, upper end of the box is the upper quartile. So this is the 4 features we are plotting 4 box plots. Right. So similarly, you can also have the plot of the density
Sir,
estimation.
Vijay sir.
So please observe this in
Sir,
the
Ravikumar sir.
Iris data frame. We use the plot for the different
Sir,
kinds
మీకు
of plots.
WhatsApp లో C
Kind is
section, D
density
section
here.
numbers
So this is giving you the density
presentation.
estimation of the different, density
మీరు
distribution of the
ఇన్స్ట్రుమెంటేషన్ వరకు
different
పెట్టేసి గౌతమ్ సార్
features.
ఫార్వర్డ్ చేస్తారా?
Similarly here, the plot kind is histogram. Histogram. This is giving you the histogram type. Right?
రెండు కాలమ్స్ లో
Here
నెంబర్స్
the
పెట్టా
plot
సార్
type is
పెట్టమంటే
scatter.
మీరు ఇన్స్ట్రుమెంటేషన్
Here
ఒకటే పెట్టాలి.
is giving you the scatter type plot. Okay. Here the
అది
kind
ఒకసారి
of
అడగండి,
plot is
పక్కన ఉన్నారు ఆయన.
hexabin. It is giving you the distribution in terms of hexabin. It means this is how the points are distributed according to the sepal length and sepal width. See, most of the point, and this is the number indicating that darker value means at this point it is 8 points are there. Here 7 means, 7 means
sir.
this indicated with this color. 6 is indicated with this color and so forth. Okay.
మీకు
The
పంపించాను
lighter
నాకు
the
నెంబర్,
color,
అది
the
ఆయన
lesser
వాట్సాప్
number of
దొరకలేదు.
instances at that particular
Sir.
point. The darker the color, it means more number of points at that particular location. Okay. Similarly, you can have a scatter matrix, something like this. Okay. You can go through all of them later, as I'm going to share this. Very easy to follow. And suppose if you want to set some, extra backgrounds, extra, improve the quality of the figure and all, there is a Seaborn library. You can set sns.s. Okay. Then the curve will be looking different. Like for example, now I have executed this, right? sns.set. Now you can see that I've executed this sns.set Seaborn library. Now let us execute the earlier things, that whatever that we have already executed. Now without setting that SNS, we have got this figure, right? After setting this SNS, I'm just executing it again. Now you see that the style is changing, right? Right. So there are some settings that you can do in SNS so that you can have a better curve. All right. So that's all. If you have any queries, I can take. Otherwise, we can quickly wind up the session. Thank you very much and happy learning. I know that it is towards the end, it is little fast and it is like a hurrying up, but go through things. If you have any queries, you can mail me. I'll give you my mail ID also. I'm just typing it in the chat box. Meanwhile, if you have any queries, you can ask me. Okay, I gave my mail ID in the chat box. You can go. I hope you have followed it. Okay, except for this data visualization part, that you can go through it slowly. Okay, and get back to me if you have any queries. So thank you very much and happy learning.
Thank you, sir. Thank you so much.